Okay, so the amplitude of this function is 6. What is the period?
2 pi over 3?
Pi over 4.
Or does the 8 come in?
8, 2 pi over 8, so 1 over 4.
Pi over 4. Yep, you take the coefficient in front of the x, and for sine, cosine, secant, cosecant, you take 2 pi over that coefficient and simplify. For tangent, cotangent, you take pi over that number and simplify. Okay? Because sine, cosine, secant, cosecant have a period of 2 pi. Okay, what's the phase shift? Well, this is something, if I wanted to get x by itself, I could rewrite this as this, right? Because this just comes up. So the phase shift is actually 3/8.
Right.
So what exactly is the phase shift?
Phase shift is how much it shifts, right and left,
Okay, well.
Horizontal.
Okay.
horizontal,
Yeah, that's what I wanted.
this way. Okay? So that was all you had to do for that one. It's multiple choice. It said identify the amplitude, period, and phase shift.
So what's the phase shift?
Phase shift is 3/8, positive. If it were x plus 3/8, it would be negative 3/8. Okay, write an equation of the cosine function with amplitude 3 and period of, I have to make something up here, 7 pi. Amplitude 3, period 7 pi. And we have to write a function, cosine. So how do I find the period from, I mean, we found the period here to be 2 pi over 8 or pi over 4, right? By taking 2 pi and dividing it by this. Well, I'm trying to find this, so let's just call that x. I have 2 pi over x equals 7 pi. Yeah. So it's just x would be what, 2/7? And amplitude's 3. So it would be y equals 3 cosine 2/7 x. Because to get period, I take 2 pi over that coefficient. If I don't know the coefficient, I'm going to take 2 pi over the period. And the pi's cancel out, so it just becomes 2/7. And the 3 just goes in front. The amplitude's in front. Okay? So far, so good? So you guys can get 2 done easily. Okay, graph this function. Theta is your variable. This one you're going to have multiple choice graphs to choose from. If it helps you, then make this an x. It's just a variable. What's the period? Okay, period is 2 pi over 3. Amplitude is 4. Shift is I think it's 1/9 pi. Because to rewrite this, I mean, basically I'd have to factor out if you want to do it that way. Right? Because 3 times x is 3x, 3 times 1/9 is 1/3. So to find the phase, to find the shift, the horizontal shift, x always has to have a coefficient of 1. So factor out what you have to get that. So it's going to shift 1/9 pi to the right, and then it's going to shift up 1. Okay? So the first thing, if you've got a multiple choice question, one of the easiest ways to narrow your search down is to find the new period, because if you can look at the graph and see from where it starts to where it ends one full cycle, what that distance is, you can match that to your period, right? So we know our period's 2 pi over 3. So in a normal cosine graph, It's going to start here, and it's going to go, this is pi over 2. I'm not putting a point there, I just want to put a dash there. Pi over 2, pi, 3 pi over 2, 2 pi, right? And it's going to go down, come back up, and end up here. So I'm just going to do one period of the cosine graph. But now, instead of 2 pi, this needs to be 2 pi over 3. This is one way to look at how to find those critical points. In the normal graph, what's the difference between each one of these? Pi over 2, right? And it's constant. It's pi over 2 every time. I just add pi over 2 to get to the next one. Okay? Well, if I want to end up at 2 pi over 3 instead of 2 pi, to get from 0 to 2 pi, to get pi over 2, I took 2 pi and divided by 4. Right? So I'm going to take this and divide it by 4. And that's 2 pi over 12, which is pi over 6. So my first one will be 0, then pi over 6. Then I'm going to add pi over 6 each time. So this is pi over 3. This is pi over 2. And then 2 pi over 3. Okay? So if you can get those critical points when you look at the graph choices, that'll kind of help you, because this now becomes pi over 6. This is pi over 3. And this is pi over 2. I just did that by dividing 2 pi over 3 divided by 4. And then just found the first one is that, pi over 6. And then I just added pi over 6 each time, because that's the same process as we get on this side. We added pi over 2 each time. Okay. Now, we shift this pi over 9 to the right. So each one of these points is now okay, get a common denominator, you can figure out what the new values should be. So this will tell me my x values. Okay, the 4 and the 1 don't change my x values. What do they change? Yeah, just my y values. Yeah, and so now instead of this being 1, it's going to be 4, and then I'm going to shift it up 1. So this whole thing is shifted up 1, so it's not going to be symmetrical around the x-axis. And the highest point will be 5. Right? This point will be times 4 shifted up 1. So negative 3. So it'll go from negative 3 to 5 will be my range of the graph. And my x values will be there. Okay, so if you can kind of get that table and figure out where your critical points should be and what the range is, you should be able to look at your graphs and figure out which one has the same period that you need, has the right shift in there, and then amplitude and shift up. Does that make sense? And the answers all have the actual amplitude, period, shift, and vertical shift as part of the graph. But there are 2 that are identical as far as the actual numbers go. The graph's not. You know what I mean? So you can at least narrow it down once you have that much, but then you'll want to look at the graph and see. Okay. Let's do this one. Let's do minus pi. Okay, graph this one. Well, for me, the easiest way to graph this one is to graph cosine. Because once I know cosine and then where cosine is 0, I can find the asymptotes, and I just find the peak and valley of the cosine graph and draw a parabola, right? So I want cosine what is the period? Eight pi. 2 pi over 1/4 is 2 pi times 4 over 1, which is 8 pi. So the period is 8 pi. You notice that if this number is less than 1, it actually elongates that period out. And if it's greater than 1, it makes it shorter. Okay, and then the shift.
Plus for right one. Oh, yeah, you got it.
Right? Because 1/4 times theta is 1/4 theta, and 1/4 times 4 pi is pi. So I always have to factor out that coefficient before I can figure out the shift. Okay? So amplitude's 1. There's no shift up or down, but I do have a shift right, 4 pi. Well, do I care if it's 4 pi? No, because if I take, well, do I? The period's 8 pi, so it's still even. 4 pi is going to be 1/4 of that period. Well, let's just do it real quick. Yeah, half. Thank you. Half of the period. So this is now 8 pi, right? That means this is pi, 2 pi, 4 pi, 6 pi. Then I'm going to add 4 pi to it. So my first point, because it's still 1, it's going to be 1, but instead of 0, it's going to be at 4 pi. Let's just call this 2 pi, 4 pi, 6 pi, 8 pi, and so on. So it's going to be 1, 4 pi. Then I'm going to have 2 pi plus 4 pi is 6 pi. And then it's going to be -1 at 8 pi. Back up and back up. So this becomes 12 pi here. Right? So to really get to, this is going to be at 0. That shift did matter. It didn't end up repeating it exactly. Actually flipped it because of this shift. You know what I mean? Okay, so I've got a little bit of my cosine graph done. I know there's going to be an asymptote here and here. Anywhere cosine is 0, secant will have an asymptote. Okay, so to actually graph what I'm looking for, it's going to look like this. And it'll be down here. Okay, so when I'm trying to find the graph, I need to match up one that splits the y-axis evenly on the downside and then goes up, down, and that with the right period. That make sense? Okay. Having the graphs there for you to see makes it a lot easier than making you graph themselves. And graph it yourself. But. Okay. Now I have a secant. What would I want to graph for secant? Cosine. Was the last one secant too? Yeah, let's do cosecant this time. A lot of 3's in this one. So I'm going to graph sine. So let's just figure out the x values for sine. What's the period? So divide that by 4. This one is 3 pi over 2, right? And each time I'm going to add 3 pi over 2. So this becomes 6 pi over 2, which is just 3 pi. And then 3 pi over 2 plus the 6 pi over 2, 9 pi over 2, and then 6 pi. Everybody see how I do that? Okay, I take this number and divide it by 4.
That's the period?
Uh-huh. I got 1/3, so 2 pi over 1/3 is 6 pi. I divide this by 4 to get 6 pi over 4, which is 3 pi over 2. That becomes my first point. And everyone after that is an even 3 pi over 2 plus that previous number. So 3 pi over 2 plus 3 pi over 2 is 6 pi over 2, which is just 3 pi. And then 3 more makes it 9 pi over 2. Okay, so I know these are my x coordinates without a shift. What's my shift? Right? Factor it out and then check yourself. If you just put it back in, 1/3 x minus pi over 3. Okay, so it's going to shift pi units to the right. Okay. Really, this doesn't really matter when you're looking at secant and cosecant. I mean, it might change the stretch of that parabola that you have, but it's going to be really hard to see. And we don't really know what those coordinates are going to be of the vertex of that quote-unquote parabola. It's not really a parabola, but you know what I'm saying? Really what we're going to be looking for are where the asymptotes are. Okay? So the asymptotes are going to happen where sine is 0, and sine is 0 here, and it should be 0 here, and 0 here. So my asymptotes are right here when I draw this graph. So instead of 0, the first point happens at pi. And then I'm going to go, what, 5 pi over 2, which is 2.5 pi. Right? Your fractions get really good in trig. Isn't that what you wanted to hear? 4 pi, which it should be right here. And then I'm going to go 2.5 more to 11 pi over 2. And then I end up at 7 pi. Okay, and so now this becomes my 1, 2, back to 0, back to -1, back to 0. That should be not a point, but a slash. Okay, my normal sine graph then from there. So I'm going to have asymptote, 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 and I can now graph it. So it looks like it's not even going to be symmetric along the y-axis, right? My next asymptote happens to be right here. And this is coming down. Is that right? That's not where the asymptote's going to be, is it? The next point would be, there's my asymptote. So it's going to be something like this. So it's not going to be quite symmetric over the y-axis. So you're going to be looking for a graph that just kind of has this general shape.
Is
I haven't done any tangent or cotangent.
that what it all mostly is just, it gives you an equation you have to graph it.
Mm-hmm. Those are these. So that's, let me look at if I have any other kinds. I have 2 tangents in here. Then this one is, do you want me to do a quick tangent? Are we okay with, okay. Let's do, okay, so it's already factored, which is nice. What's the period? What's the coefficient of x? 2.
Oh, because it's back here.
If I put this back in, it's 2x, it's tangent of 2x minus pi, right? So 2 is in front of the x, so I take pi over 2 because pi is the period of tangent. So the period of this is pi over 2. The normal period is pi, so it's going to be, there's going to be more tangent graphs within the same amount of time. Okay, and then it's going to shift right pi over 2. So the normal asymptotes for tangent happens when cosine is 0. And cosine is 0 at pi over 2, 3 pi over 2, and those iterations. Okay, so maybe it would help if let's do y here. Y is, for a tangent, it's 0 when sine is 0, so it's 0 here, here, and here.
Pardon the interruption. Teachers, please dismiss the JV football players at this time. Good luck, boys.
Asymptotes there. So a couple of points that are handy with tangent. Pi over 4, 3 pi over 4. Pi over 4, tangent's the square root of 2 over 2. No, tangent's 1, sorry. Right, because it's 45 degrees. Tangent of 45 is 1. So pi over 4 here is 1. 3 pi over 4, which is the second quadrant, is negative 1. 5 pi over 4, which is the third quadrant, we're back to 1, and then negative 1. Okay, but now from here, these are all going to shift right pi over 2. So my first asymptote is going to happen at pi over 2, pi, 3 pi over 2 pi, and so on. That's just pi, 3 pi over 2. So this is my first asymptote because I'm just moving everything plus pi over 2. So at, this is 0, and I know at pi over 4, it's 1. Well, if I shift pi over 4 over, it's here, right? So at 0, we also have an asymptote. Let me do those. And my graph is going to go this way. And the period we said was pi over 2. Does it look like I did that? Looks to me like the period's pi. So I did something wrong. 0 plus pi over 2 puts me with an asymptote here. No, that's where it's 0. And I'm going to have an asymptote here and here. So it's, I mean, basically you have 2 complete rotations in a normal pi period, right? 2. It's going to come down through here, and so on. Okay. Just write your normal x-coordinates and add pi over 2 to each of them. And then you'll come up with your new values. And there's no negative, so it's going to be from right to left with tangent. So if you have 2 of the 4 graphs that are going left to right, you know those 2 can't be it. Now you can narrow it down to the 2 you have.
Wait, if it's negative, then it's...
If it's a negative in front of it, it's going to flip it over the x-axis,
But won't
which
it
means
go back to left or left to right?
the negative in front of it.
Oh. Oh, yeah.
Yeah. Okay, so the last kind of question here is it gives you, I want you to write a sine function when the period is, the amplitude is 3, the period is pi over 2, phase shift is negative 1/3 pi, and the vertical shift is negative 2. So this is horizontal, this is vertical, this is period. Okay.
Write a sine.
Yeah, sine function. What do you think?
3 sine.
Okay.
And then
The period's pi over 2, so what's the coefficient of x? Two pi divided by pi over 2. So 6.
yeah.
Or 4, sorry. Pi over 2.
Just 4.
Yeah. 4. And I'm going to leave the 4 on the outside because it'll make it easier. This horizontal shift becomes x plus pi over 3, right? Because it's minus.
Isn't it 1/3 pi?
What, same thing as pi over 3,
Oh, yeah.
isn't it?
Yeah.
So it would really be 3 sine 4x plus 4 pi over 3 minus 2. Okay. This one is determine the amplitude, period, and phase shift for y equals 1/6 cotangent and then use them to plot the graph of the function. So the amplitude is what?
1/6.
1/6. The period is
2 pi over theta.
theta is your variable, x. So if it helps you and you see that, what's the period of cotangent? Pi.
Pi, yeah.
So the period of this is pi. The shift is 30 degrees left. And the amplitude's 1/6. Okay, so it's basically, period doesn't change, but now every time there was an asymptote before, which happened at any time cosine is 0, so the asymptote happens at pi over 2 3 pi over 2, 5 pi over 2, 7 pi over 2, any iteration of pi over 2, right? Odd iteration, I should say. Now that pi over 2 asymptote actually shifts over pi over 6, or 30 degrees. Well, if it's in degrees, that's a little easier because the asymptote's happening 90, 270, and so on. So instead, now we're shifting that from 90 to 60. Right? So the asymptote happens at 60, and from 270 shifts over 30 degrees. So the next asymptote happens at 240. And then we go to further with pi over 2 or 90 degrees beyond, and you know what I'm saying? So it used to be our asymptotes happened at pi over 2 and negative pi over 2. But now this is going to shift 30 degrees, wherever that ends up being. And when I draw it at positive pi over 4, that's where it's 1. So it's always going to go, so it's going to go like this. So it's not going to go right through the origin now. It's going to, that point that it goes through is actually going to happen at negative 30. Because it all shifts over at 30 degrees. Okay. And the last one is another that just says graph 2 cosecant theta minus pi over 4. 2 cosecant well, which one should I graph? Sine or cosine? Sine. Luckily the period's still 2 pi. So the only thing that shifts is every point on here shifts 45 degrees. Okay, to the right. So whatever that ends up being. Make that the new one. And then this becomes 2, negative 2. So my asymptotes now, instead of being right on the x-axis or y-axis, it's supposed to be there, or there. Okay. Really just being able to recognize what that period change and shifts do to the original graph, what the original graph looks like. I think last year's class, the very first question that asked you to graph had all the answers on the next page, so they spent all their time physically graphing it, and they got to the next page and were like, all the answers are there. Yeah. But it would be good to sketch it, you know, just kind of get a general idea of, does it start up or down, and is there a flip, or what the period is or what the shift is, but all the graphs are there. So, all right.